Hi, in this video we'll be looking at the Newton-Raphson method and how we can use it to solve for the root of an equation.
Now, what exactly is the Newton-Raphson method over here? Now, this method basically revolves around a formula or an expression which can be written as x to the n plus 1 is equals to xn minus f of xn divided by f prime of xn. So this f prime is actually the first derivative of f of xn. Okay, now as you can see, what we need to do is we need to iteratively keep on doing or computing the xn plus 1 until we find that it converges to a value. Okay, and that value is basically the root of the expression. Now, in order for us to do this, we must start off with an initial value for x0, and that value for x0 should be obtained by looking at the value of fx, okay, where we know that there is a sign change that is going to happen. All right, now let's take this expression. For example, fx is given as x cubed minus x minus 1. Now if I were to substitute x equals to 1, f of 1, I will get 1 cubed minus 1, which is equals to minus 1, and this is less than 0. Correct? If I were to take f of 2, okay, I will get 2 cubed minus 2 minus 1, which is equals to 5, and this is greater than 0. So with that, we can say that there is definitely a root, okay, between, okay, x equals to 1 and x equals to 2. Okay, so there will be a crossing, okay, of the curve from the negative to the positive between x equals to 1 and x equals to 2, x equals to 2. So there is a root present between this range. Now, since we know this information right now, we can use x0 equals to 1 as the starting point. Okay, so that is the first step. We need to come up with a starting point, and the starting point should be somewhere where we know that there is a crossover going to happen. So we do not know exactly where it is going to be, but we know that there is a crossover from the time when x equals to 1 till x equals to 2. So we can start off with saying x0 equals to 1. Now, let's look at the expression fx. So if fx is given as x cubed minus x minus 1, then f prime of x, which is the first derivative, will be given as 3x squared minus 1. Okay, now putting this two terms into this expression over here, we can say that x of n plus 1 is equals to x of n minus xn cubed minus xn minus 1. This is your fx divided by f prime of x, which is f xn squared minus 1. Okay, so now let's start off with x0, which is equals to 1. Okay, so since we know x0 equals to 1, we can go and compute x1, which will be equals to x0, okay, minus x0 cubed minus x0 minus 1 divided by 3 x0 square minus 1, and that will be equals to 1 minus, so x0 is 1, correct? 1 subtract, so 1 cube is 1 minus 1 divided by, okay, x0 is 1, so 1 square is 1 times 3 minus 1 is 2. All right, and this 1 minus 1 will be minus 1 over 2, so minus and minus will give us a plus, so 1 plus half is 1.5. Okay, so we have moved from 1 to 1.5. Now we need to iteratively keep doing this process again and again. So x2 will be equals to x1 minus x1 cubed minus x1 minus 1 divided by 3 x1 square minus 1. Okay, and that will give us 1.5 minus 3.375 minus 1.5 minus 1, divided by 5.75. Okay, and that will be 1.5 subtract 0.15217, it should be equals to 1.34783. Okay, so we are moving closer to the values. Okay, but we still need to keep on doing until we see that the difference, okay, between the new x value and the previous x value is very minimal, okay, or they are the same. Okay, so let's go on to find x3. Okay, so as you can see, it is the same formula. Okay, and we just need to keep on updating it with the new values. Okay, so x2 cube minus x2 minus 1 over 3 x2 square minus 1, and that will be equals to 1.34783 minus, okay, so I will leave it to you to uh, figure out all the intermediate values. I'm just going to give you the final values here. So 0.1006995 divided by 4.449937, and that will give me 1.32520. Okay, so the next one, which will be x4, will be x3 minus x3 square minus x3 minus 1 over, sorry, here's a cube here, okay, and 3x3 square minus 1. Okay, and that will give me 1.3252 minus 0.0020566 divided by 4.268465, and that will give me 1.32472. Okay, and let's do one more. x5 will be x4 minus x4 cube minus x4 minus 1 divided by 3x4 square minus 1. Okay, and when you work out this, you will get the same answer as x4, 2472. Okay, so you can see that at this point, the values between x5 and x4 are actually the same. I mean, the values are the same. So you can conclude that we have converged to a final answer over here, which is 1.32472. So this is the root, okay, for this expression, okay, using the Newton-Raphson method. Okay, as you can see, the important step is in the beginning to make sure that you are able to find the values, okay, where the fx gives you a change of sign, okay, and with that change of sign, as you can see here, okay, we will be able to know that a root lies within this x range, and then we take one of it as the starting point, in this case x0 equals to 1, and from there we keep on doing the same process again and again till we converge to a final answer over here. Alright, so that's how you approach a question using this Newton-Raphson method. Thank you very much for watching, and I'll see you soon in my next video. Thank you. Bye.